Good afternoon, or good early evening for those of you in Turkey. Really literally just realized you're 1 hour ahead of where I am at the moment. So it's almost evening for you. Yeah, really looking forward to this talk. Thank you again to Egemen and to Bas for having me, for inviting me for this to do a little talk on test automation strategy. My name is Bas Dijkstra. I live in the Netherlands. I've been a test automation consultant for some 15 years now. And in September, I joined a South African-based company called Inspire Testing, where I am in charge of their academy, which means I'm responsible for designing and delivering software testing and automation training to the people in the company, but also to their client base. And their client base is not just in South Africa, but increasingly global, and so is their workforce, which I am proof, so to say. Let's start talking about test automation strategy, because that's what you came for, and not for to listen to me talking about myself for an hour. Hopefully not. So as I said, I've been in test automation engineer, and later a consultant for some 15 years now. And that means I've been talking to a lot of people and teams and organizations about test automation. And the thing that I've noticed is, and that's still very true, is that when I ask people, teams, to tell me a little bit about their current test automation strategy, the first thing that always comes to mind, or the first thing that people start talking about, are tools. So whenever I ask someone, what's your current test automation strategy? How do you approach test automation? Almost always they're going to tell me about the tools that they're using. And to some extent, I can understand that, because tools are the fun part of test automation. I love tools. I love learning about new tools. I love exploring what tools can do, how tools can help me write my tests more efficiently, to support my testing. But I don't think a good test automation strategy should start with tools. There's much more to creating a good test automation strategy than just thinking, what tools should I use, and what's the best or the most suitable tool for my specific situation, for my specific context, for my testing and automation requirements. To put it another way, when I ask people about their test automation strategy, they almost without exception talk about the how of test, how they are automating the tests, meaning which tools they are using to write their automation. But that's only a very small part of a test automation strategy. And starting with the how is often a really bad idea. Deciding a good test automation strategy does not start with picking a tool. The selection of a tool should be the logical result of answering a number of other questions. First of all, the why. Then the what, the who. So who's going to do the test? So first, why they are going to do test automation in the first place? What are we going to use automation for? Who's going to write the automation? when are we going to write and when are we going to run that automation? And where are we going to automate? So these are all questions that I think are incredibly important when you're creating a test automation strategy. But in practice, a lot of these questions are simply skipped in favor of, well, let's pick a tool and see what we can do. So a lot of people, when they talk about test automation strategy, they talk about the how, thereby forgetting the why, the what, the who, the when, and the where. Turns out you need those. You need answers to all of these questions if you want a solid test automation strategy. And that's what I want to talk a little bit about in this session, about those very important but often forgotten questions that I think are key when you define your test automation strategy. This is not something I've come up with myself. I've found it to be incredibly useful to get the conversation going, to have and to help people focus on the important questions when it comes to creating a test automation strategy. So these 6 questions are also known as the Kipling Method. After Rudyard Kipling, I think he was English. He was a writer, and he came up with this method. If you want to learn more about it, I'm not going to go too deeply into the technicalities and the theory behind the method, but I've been using these 6 questions before I knew it was called the Kipling Method, but turns out there's a name for it. So if you want to read more, just Google the Kipling Method, and you'll find plenty of materials, articles that explain a little more about these 6 questions and why they're so important. So like Simon Sinek said in his famous book, Start With Why, let's start with the why. I think that's the most important question in any test automation strategy, really. And the question that the entire strategy, creating your entire strategy, should start with. Because if you don't have a valid, accepted, and shared answer to this question, I don't think there's a point in spending a lot of time and effort on test automation at all. You need to know why you're doing it. So why? That's the first question I ask people and teams when we start discussing test automation implementation, test automation strategy. Why should we automate? Why do you think you need automation in the first place? What they often come up with are some automation goals. So the first time I asked them the first time I asked this question of why do you think you should use automation? They come up with a question like, we want to automate because we don't want to do our regression tests manually anymore. That's a common answer. I don't think it's a very good answer, though. Why? Because that doesn't tell me anything about why you should do those regression tests in the first place. So I said, why do you want the regression tests automated? But because we don't want to do them anymore. And why do you want it? But this answer doesn't tell me anything about the value of those tests. So it doesn't tell me anything about the value of automating these tests. The general problem is that automation and even testing in itself is not the goal. So the answer to the why should not be an answer in terms of testing. The result of the value of automation, it should be a business outcome. It should express what this effort, the time and the effort and the money that you invest into automation, Yeah, you should answer the why in terms of what does it bring for the business? What does it bring? What value does it bring to either my product or my process? Because nobody wants to pay for tests. So at least I've never had a customer said, well, give me 50 pounds of automated tests, please. Nobody is, because nobody wants to pay for it. Everybody wants a high quality product, but nobody wants to pay for tests. So if we define goals of our testing, and more specifically in this case of our automation, we should express that in terms of what value does it bring to our product or our process. You could even call testing waste in terms of manufacturing processes. Then again, if you check the lean principles for manufacturing, defects are waste too. So there's probably some point and some value in this whole testing thing again. But the most important thing is express these goals in terms of business value. What does the automation enable? Does it enable, for example, does it enable you to shorten the feedback loop and thereby getting and releasing more frequently, or getting insight into the quality of your product more frequently? And then what does that in turn, what does that enable? Does that enable us to release more quickly and release with more confidence, and increase the chance that our end users or clients or customers are actually happy with the product that we're delivering? Can we deliver more often than we could before we started this whole automation journey? Those are business outcomes. That's business value. That's value that's actually added to the product, the process, or value in the eyes, in the perception of your stakeholder, not just value in terms of the testing process. Because again, nobody wants to pay for testing anyway, so it doesn't really make sense to try and sell automation, so to say, just in terms of testing. The second question in our automation strategy is the question of what should we automate? And it turns out, if you look a little deep, there's a lot of different things that we could automate. So what should we automate? One of the things that and there's no one size fits all answer, unfortunately, to this question. So it all depends on the context, really, your specific situation. But there are a lot of different types of tests that you can take into account when you start discussing, what should we automate? One thing that's often forgotten is static code analysis and linting. And that's a fairly cheap way to add quality to your code and improve the process and improve consistency in different coding styles, and it improves the way you can talk about or communicate about code. So it's relatively easy to implement. So that's where I should start. Is this something that we want? Turns out a lot of developers actually already do this. But if they don't, it's definitely worth considering. Of course, you've got unit tests on your source code. Those are hopefully things that a lot of developers are doing already. But if not, it's definitely something that you should consider doing, because in terms of automation and the time it requires for the tests to write the tests, unit tests are fairly cheap because they are quick. It should be relatively quick to write these unit tests, and they are quick to run. Of course, you've got your integration tests, potentially via an API layer, those tests that are checking, verifying business logic. Your end-to-end tests where you do end-user simulation, often through a graphical user interface, but not always. And of course, there's all the other kinds of tests like performance tests, security tests, you name it, accessibility tests, tests for usability, although those are often pretty hard to automate, but in terms of testing, they're definitely important to consider. In the end, in answering the question of what to automate, it's the thing that you should keep in mind that the goal for one of the primary goals for automation is getting fast feedback. You want to automate specific tests because you need specific information as fast as possible, really. Because you want to speed up your integration and deployment process, your build process. So you want information because testing is all about uncovering information, and automation is nothing more than using tools to get that information more efficiently. And the most efficient way to do that, the smaller the test, the more efficient it typically is. So the quicker, the easier it is to write, the less time it takes for you to write them, the quicker they run, and the faster you'll get the feedback. So, and whenever you try and decide, well, what should I automate? Always think, what kind of tests give me the fastest feedback? What kind of tests help me get the important information as quickly as possible? And that means keep your tests as small as possible. Running tests early and often and including that into your development and testing process. And instead of testing as much as you can and automating as much as you can, try and at least see it from a sort of kind of different perspective. Even if only to challenge the notion of we're going to test and or automate everything. Why not just ask, why don't we try and aim for testing and automating as little as we can get away with? So, and that means that, so as long as our most important risks are covered and we uncover the most important information, why not stop there and see how we do, instead of spending lots and lots of time and effort, and again, therefore money, on trying to increase your test coverage to all the nooks and the crannies and all the different little corners of your application. There's this nice rule called the Pareto Principle, which says that you get 80% of the value from 20% of your efforts. That applies to testing and automation as well. So yeah, why not, instead of aiming for 100% coverage, see how much coverage you can get with 20% of the effort. And if you want that feedback early and often and run your tests early and often, it's probably a good idea to integrate them into an automated pipeline. But we'll talk a little bit more about that in a couple of minutes. I said earlier, when I hear people talking about what to automate, the first thing that comes to their mind is our regression tests. We want to automate all of our regression tests. And I'm sure that at least some of you have heard this, have tried this, and some of you might have even succeeded with it. Good for you. However, it often comes with a lot of challenges, automating regression tests. Why? Because regression tests especially if you go through the motions of we've got a collection of existing regression tests that we want to automate because they take a lot of time, they're boring, and we want to do the interesting stuff. Those are all good reasons, but there's a problem with these regression tests when it comes to automating them. And that's that these regression tests are written by humans for humans, which means that tests are often written down either with a lot of detail that doesn't really make sense to put all that detail in your automated tests. And they often are written in a way to make it easy for humans to execute them, which means that they'll often operate on the graphical user interface layer of an application, which is the interface that is specifically written for human beings. The problem is when you start using automation to execute those tests, you're not using humans anymore. You're using computers, you're using tools, you're using code to try and replicate what humans do. And that's not as easy as it sounds. There's a heavy focus on GUI interaction, and these graphical user interface tests with tools like Selenium or Cypress or Playwright or you name it, those are actually the hardest tests to write. Yet almost everybody starts there with their automation efforts. Also, because of this, so to say, and because of the fact that these scripts are written by humans for humans, trying to translate them one-on-one to scripts is not often effective. Because the scripts are long, they have a heavy focus on interacting with the graphical user interface. So if you decide and start your automation efforts with your regression tests, please take time and plan a scheduled time to do a reanalysis of them. See where you can divide these scripts up into small segments. See where you can avoid the graphical user interface to get specific bits of information that are maybe in a database or exposed through an API, or that you can extract from the implementation, maybe directly by running some unit tests on code. Because all of those interfaces, the code, the database, the APIs, they are written for computers to be consumed. And that makes it that makes those interfaces much easier to automate when compared to a graphical user interface. The third question really is, after the who and the what, is where in our application can we automate? And that comes down to, that boils down to how testable is our application actually? How easy is it to test and to write automated tests for our application? How easy is it to create the initial state that a lot of our tests require, to create specific data in a database, or put orders in a shopping cart, or to clean because we need a clean environment to run our tests, to clean all the existing data out of our current instance of the system that we're testing against. How observable is the application behavior? How easy is it to use tools to get information about the current state and the current behavior of our application? And how easy is it to diagnose the application when things seem wrong or different? So, and these are all questions that affect the testability, that focus on the testability of the application. And if our application is not easily testable, it's often very hard to, first of all, test it. That's the whole definition of testability, but also to write automated tests that can help you do that testing in a more efficient manner. And these do not just apply to testing in test environments or in development environments. These apply to testing in production too, because some tests are just easier to do in production these days instead of in a pre-production or a development or integration or an acceptance or a test environment or whatever kind of environment you have. Especially things like observability are increasingly important if you want to do certain tests in production. Automatability is part of testability, really, and specifically concerns how easy is it to write automated tests for our application, really. Things that come into consideration here are how easy is it to write unit tests for our application code? How testable is our application code, really? Is it easy to access business logic through APIs? Because again, it's much easier to write automated tests that operate on the API level compared to tests that operate on a graphical user interface level, for example. So if you're testing business logic, that'll often be exposed to the graphical user interface via APIs. It will not be implemented in the graphical user interface itself, hopefully. And therefore, you don't actually need that graphical user interface, especially not in automation, if you want to verify that business logic. And if you do need that graphical user interface, how easy is it to uniquely identify elements on your screen? How and for those of you who've worked with Selenium or Cypress or Playwright or whatever tool it is that you use, or Appium maybe, how often can I use an ID to uniquely identify, or a name attribute to uniquely identify an element? How often do I need to resort to XPath or CSS locators? And how complex are these locators? What can I do to improve that? How willing are the developers of the application to help me, or even better, to facilitate me and teach me how to do it myself, from a tester's perspective? And that's all part of automatability. And the problem with this, and that's one of the problems that that you'll often have to suffer from when you're automating regression tests, because by definition, regression tests are tests on an application or part of an application or the parts of the code of an application that have been built at some time in the past. Sometimes that's a day, sometimes that's a week, sometimes that's months. Testability and automatability are not easy to introduce afterwards. And if they can be introduced afterwards, it often requires significant rework, and nobody wants to pay for rework because nobody wants to pay for testing. So it's very hard to convince developers and product people and business analysts and your CEO or whoever to postpone the release of that key feature that all of their clients are waiting for in favor of spending extra time and, again, money to improve testability and automatability long after specific features have been developed. So if it's possible from a technical point of view, it's often a problem from a process and a business and a money point of view. And that's, again, the problem with our regression tests, because, at the actual development of those features is in the past. It's done, it's delivered. So why bother with improving testability and automatability? These are things that are much easier to take into account when you're actually writing the code that implements the feature. So we've covered the why, the what, and the where. Let's look at the when. And the when is actually a two-part question. A, when should we write our tests? And B, when should they be executed? So first of all, let's have a look at when should tests be written. And again, like I keep coming back to that problem with automating existing regression tests, because that's just a very good example of how that can actually lead to bad performance and less than ideal results when it comes to automation, because I want my tests to be written as close to the implementation as possible, which means that there should be as little time as possible between the writing of the code that implements specific behavior in my application and the writing of the tests that tests if that behavior was implemented correctly. Preferably, I want to do that before I want to write the tests before I write the implementation, because A, that guarantees that I'll at least have the tests that can verify the behavior, and B, it automatically ensures that my application is testable and automatable because I already have the tests. So writing tests before writing the implementation is one of the most efficient ways of actually making sure that your application is testable and automatable. There are a couple of different ways to approach this. You've probably heard of them before, but TDD does exactly this, test-driven development. And that's, for those of you not familiar with test-driven development, it's a practice where developers write a unit test that fails, but that checks part of the behavior that's to be implemented. So they first write a test that fails, then they write as little code as possible to make that test pass, and then they do some refactoring to optimize the code before they move on to the next cycle. And implementing a feature can be a cycle of dozens and sometimes hundreds of these little TDD cycles of red, failing test, green, passing test, and refactor. So that's the classical cycle of TDD: red, green, refactor. So failing test, passing test, refactored code. On a slightly larger scope, you can do something similar with acceptance test-driven development, where test-driven development is a practice typically that focuses around unit tests. ATDD focuses on acceptance tests. So tests written from an end user perspective, where TDD and the tests in TDD often focus on behavior at the code, so at the class or the method level. ATDD focuses on writing tests first at the end user level, that tests that verify behavior at the end user level, the acceptance tests, so to say. And the third one is BDD, which is another form of specifying behavior rather than rather than writing tests. They talk about specifying behavior, but the idea is somewhat the same. So you specify the behavior and you agree on what your feature or your application should be doing before you actually start writing the code that implements that behavior. And this means that you'll always have the tests, because in BDD, those specifications in this, often in a given when-then format, they are transformed into executable specifications, so automated acceptance tests. So that also added, so with BDD2, you've got your tests, your executable specifications, before you implement the actual feature, and that ensures that you have a good and good in terms of coverage and completeness, and agreed upon and shared set of tests before you start writing the application. So these three techniques, TDD, ATD, BDD, can be a massive help, not just in streamlining your process, but also in improving testability and automatability. So, and plus it ensures that you actually have the time to write your tests, because if you write tests after the implementation, you won't often have the time. So if you start with the tests, you'll always have the time to write your tests, because tests come first. Yeah, I think I've pretty much covered this one. Writing tests after the fact, not often a very effective approach. So the second part of the when is, when should the test be run? So that's also part of my test automation strategy, and not just when should I write these tests, but when should I run them? And the only real answer, of course, as a consultant, the only real answer I can give is it depends. But in general, as early and as often as possible. So the earlier I can run my tests, and the more often I can run my tests, the earlier and the more often I get feedback about the quality of my application. And the faster my tests actually run, the faster I get that feedback. So a good idea in this is to have your tests included in a continuous integration pipeline, a pipeline implemented in Jenkins, in GitLab, in Azure DevOps, in whatever kind of continuous integration and continuous delivery platform you use. Because this at least ensures that your tests will actually be run, because there's nothing sadder than a beautifully written test that's never been run, because that is of no value at all. Tests only become valuable when they're actually executed. And one of the considerations is when do I actually, where in my pipeline will I run these tests? Well, you've got some decisions to make there. What stages do I break my pipeline into? So typically you start with things like linting, static code analysis, unit tests, and only if they pass those at first stages, then you move on to the integration and then to the end-to-end test, because it doesn't make sense to run those time-consuming end-to-end tests if there's a number of unit tests or integration tests that are already failing. And you can even go as far as running certain types of tests, and specifically this would be the linting, the static code analysis, and the unit tests, before you even commit your application code to version control. So that means that all code that goes into version control at least passes all of my linting, static analysis, and my unit tests, for example. And so you're never accidentally entering code into your version control system that doesn't meet at least part of the quality criteria that you expressed in your test suite. The final W question. So we've got why, what, where, and when is the who. Who's going to write all these tests? And what I've seen is that the whole traditional developer is responsible for the unit tests, if they even do that. And the rest is the responsibility of the testers. This, call it a traditional division of labor, doesn't really work because it creates artificial silos, buckets, boundaries, whatever you want to call them. And where you have these silos, you don't have communication and shared understanding and an exchange of knowledge and working together. And as a result, you'll have probably end up with gaps in your test coverage or a lot of inefficient tests that basically for example, a lot of inefficient integration or end-to-end tests that basically repeat what the developer already covered in their unit tests. So at this whole traditional, let's have the developers work on the unit tests, and for the other task on our Scrum board, on your Kanban board or whatever you use, let's assign those to the testers. That's not really working. So at the who part of your strategy, it should be who does what, but please try and avoid that traditional division that you saw on the previous slide. I still believe that developers are best equipped to write unit tests because they write the code, they write the application code, so they know how the code works, how it's structured, so they are best equipped to write the unit tests. That doesn't mean, and ideally they do that in a TDD-like fashion, so close to implementation, so close to writing the actual application code, and if they can, before they write the application code. That doesn't mean that testers can't be of help, can't be of value when it comes to unit testing, because they can. They can help, and a good way to work together is by pair programming. So by implementing a feature together, together I mean a developer and someone with a traditional developer hat and someone with a more traditional tester hat on. Why? Because you get the 4 eyes, 2 know matter, 2 see more than 1, 2 know more than 1, and you've got a tester whose strong point often is asking the questions about what else could happen, what could go wrong here. Are you sure it's meant to work like this? Are you sure that this method or this class never receives an input that's negative, or that's how do you make sure? Shouldn't we write a test to make absolutely sure that it can, because I've seen this somewhere else? So that makes working together on these, also on unit tests, and if you don't like pair programming, you can do it through things like code reviews, but that's less efficient than actually pair programming, because that's where the discussion and the sharing of the knowledge happens if you work together on a specific task. And that task is then writing tests and writing code that actually brings business value. Oops. And this collaboration, it extends to other types of tests too. So that's not something that should be reserved exclusively for unit testing. And in general, I think the pair mob programming, also in integration tests and end-to-end tests, works really well. Why? Again, you have a transfer of knowledge, of skills, of experience. And while it might seem slower in the short term, you'll almost definitely benefit from it in the long term, because now just not developer A knows how something is implemented, how this works, but also maybe a developer B or tester C knows about how a specific feature or a part of a code of an application or an application is implemented. And so that goes, and the transfer of knowledge and skills and experience really goes both ways. So it's not just testers helping developers, it's also developers helping testers. And this close collaboration, and this is something that we've seen happening in the testing world in recent years anyway. This whole traditional division between developers and testers is blurring. I wouldn't call it disappear. Yeah, I said disappear. I write disappear, but it might be it's the traditional division between developers and testers is blurring. And people still have their strong points and they're specialized in something, but developers increasingly often pick up testing tasks, and testers increasingly often pick up or are expected to be able to pick up certain developer tasks. And that's not just writing the application. Developers do a lot more than just writing application code. There are definitely a lot of things where testers can help out too. But it does have an impact on the skill set required of those testers and of your developers as well. So where traditional developers often said, well, I don't do testing, my code just works. That's not an attitude that's really widely accepted anymore. And the same goes for the tester. The tester that just says, well, I'm waiting on the requirements, I'm using my test design techniques to create wonderful tests, and I'm going to execute them once the developer has finished their job. That still exists in some places to some extent, but let's call it modern testers or the 20 testers nowadays are often expected to chip in to development tasks as well, to help developers out, and that blurs this traditional division, this line between developers and testers. I think that's a good thing. It's exciting because it means that there's a lot of opportunity to learn new things. But it is something that you need to take into account when you compile your teams, when you put people together in teams, when you and also if it probably has its effect on how you actually develop software and what your process looks like and the way you upskill and train your people, because and now testers need not only be experienced in test design techniques, for example, but also in communicating with developers, in knowing more about the internals of the application and the way the developers do their work and how they can help there. That doesn't mean that everybody needs to be able to do everything, but I see it. I prefer to see it as roles that are expanding and roles that are becoming more broad. And again, each person still has their own specialization and their strong points, but apart from that, you're now expected to do more, and that means that your way of working and the way you train people needs to reflect that. So I've been talking for almost an hour, and we're finally coming to the tools. So the final question in our test automation strategy is, how are we actually going to implement these tests? And again, that comes back to the tools. But that question, you can only really effectively answer that question if you have an answer to all of the previous questions: the why, the what, the where, the when, and the who. Because only then can you find a tool set that fits what I call that context. Those 5 W questions, the why, what, where, when, and who, they shape that, they give you insight into the context. They shape that context, and having that context and that all those fundamentals of your test automation strategy, they help you. They help you pick a much more efficient a tool set much more efficiently, because you know who is going to write the tests. You know what you are going to test. You know when you are going to test it. You know how you're going to integrate that into a pipeline, and that makes it much easier to pick a tool that supports that context and that fits that context. So things you should take into account here when you're writing a test automation strategy. It's not just, and one tool is not going to cover it. It's not just one automation tool that can solve all of your problems, which means that the people who are going to work on the automation, the developers, the testers, I don't care really who's going to do that, but they need to have at least a sort of kind of working knowledge of different kinds of tools, again, including linting and static code analysis tools, unit testing frameworks, API testing libraries, UI testing libraries, performance and security, accessibility, UX kind of tools, continuous integration orchestrators, because these are all part of your automation strategy, implementing that into a CI pipeline. If you so knowledge of Jenkins and GitLab and Azure or Azure DevOps or whatever. You're probably using some sort of version control, and Git is incredibly popular right now. So you need knowledge about that as well. Cloud and container platforms like Docker or Kubernetes, also, or again, Azure or AWS maybe. Also incredibly important to know, because these are all part of the belt or chain of tools that you need to successfully implement that automation strategy that we crafted. And of course, and we didn't really talk about this a lot, because what I've talked about is a test automation strategy. But how does this is something that definitely also needs to be addressed. What about the exploratory? Manual testing is a bit of a tricky word in some contexts or with some people nowadays. So let's stick to exploratory testing. Even your test automation strategy should address how this fits in, because you're never going to be able to automate everything, no matter what tool vendor A or manager B says. There's no such thing as 100% automation or automating all of the testing, for crying out loud. So please, even if you're devising a test automation, keep in mind that there's also lots of things considering testing that are and even so I was going to say not supported by tools, but even exploratory testing can be supported by tools. But there are lots of things that cannot be done by tools alone, where you actually need human beings. So please also make room in your test automation strategy for the human factor in testing. Let's call it that. Finally, so we've covered all the questions of our test automation strategy. Where to start and the only thing I can really say here is, like with so many things, if you start your test automation journey, is starting small. Learn from your mistakes, because you're going to make mistakes, but at least try and learn from them. So work in short cycles, starting small, and that allows you to learn from your mistakes and to correct course along the way, because you're never going to get this right from the start. Really, you don't. Use tools wisely and know that they are meant to support your testing and to support human beings, not to replace testing and replace human beings. Run your tests early and often, because only then they'll actually add value. Shift left, but also right. So try and test as early as possible, and to do a lot of testing as early as possible, but also consider maybe I can put this off. This part of testing or this part of information gathering is maybe more efficiently done at a later stage, and that later stage might be your production environment. And always keep that end goal, that why, in mind. Keep in mind every now and then, take a step back and say, well, how are we doing? Is everything that we're doing still contributing to our end goal, to the why, to what we originally had in mind when we started this whole automation journey? That's it from my end.